All right, today our goal is to determine a line of best fit and understand the limitations of the data. All right, so the line of best fit. First of all, you know that a line of best fit is drawn through data points in such a way that it best represents a linear relationship between the two variables. Okay, now the purpose is to extrapolate or interpolate the data. So what does that actually mean? Well, if this is my data set, my scatter plot, and I draw a line of best fit, and I'm going to say it's roughly that. Okay, so, and I'm going to change, no, I think I'll keep it at that same color. So these words, what do they mean? So let's pull them out and look at them a little bit closer. So extrapolate means that right now I only have data that fits between here and here. Okay, so I have some type of data that's been collected. Now, in most cases, what I want to do is I want to extend my line to find out what happens where I don't have information. So that would be extrapolate. Okay, so it means that I'm extending my line where I do not have any data and making predictions. So what it means is extending. So hold on, I'll just switch over to my writing pen. So what we're doing here is we're extending the line where currently no data exists. Now what that means, sorry, exists. What that means is hopefully my line of best fit has a strong correlation so that when I extend that line, the predictions I'm making are going to be good. Okay, so that's called extrapolate. So it's outside of the range that I have. Interpolate means almost the same thing in the sense that if you notice, for instance, I do not have any data in between these two locations here. Okay, I have data above it and below it, but nothing in between. So inter means inner. I'm making inner predictions based on my line of best fit. Okay, so what we could put for that one is we could put predictions based on predictions based on data on either side. Now, remember too, when we're doing a line as best fit, again, it's it's like an educated guess in the sense because I don't have any data in the middle. I don't have any data at the extremes. So again, I'm just making predictions based on that. Now, one of the problems that we have is a thing called outliers, and these are data points that lie far away from the main cluster of points. Now, we saw some of this in our previous unit that there just seemed to be this odd point that didn't fit everything else. Now, what they really are is they're like an exception to the rule. So everything follows this way except one or two things. So if we look at the example that you have in front of you, what we're talking about an outlier, the outlier is this point here. So everything else appears to be in this downward trend, and then I have this point way out in the middle of nowhere, so to speak. Now, what do you do with something like that? Now, you're going to see when we go to the next page that if I don't deal with it, when I make my line of best fit on the graphing calculator doesn't understand that this is the exception to the rule point. Okay, so sometimes what we need to do is we need to really go into the graphing calculator, for instance, and to literally remove that point. Now, if I'm drawing a line of best fit based on a paper model, I have no problems in looking at this and as a human being saying that point is an exception to the rule, so I'm going to not consider it in my calculation. Okay, however, the graphing calculator doesn't have that reasoning power that your brain does. So let's look at outliers and misuses of scatter plots. If we look at the first one, I would say that that is fairly representative of a line of best fit. You could argue that maybe it should be a little bit lower or slightly on a different angle, but for the most part, it's pretty good. So we're going to give that one a check mark. It looks pretty good. If we look at the one to the right of it, the problem with this one, if you had a scatter plot like this, you would not use a line, you would not use a linear model to represent this data. So what they've done is they've used the wrong regression. So we're going to put wrong regression used. Regression. And based on what we see here, I would expect that you would choose quadratic. Quadratic should be used. Now we're looking at our bottom two examples. And you can see this is the one where the outlier is the problem. Okay, the outliers here is creating an issue because what's happening is my graphing calculator, if you notice, it does not too bad a job here, and then we would assume that the line that we really would want if we were drawing it by hand would be something like that. And that fits all of these other points really well except for this outlier. So what's happened is the graphing calculator is pulled up by that outlier. And so it creates a line of best fit that really doesn't represent the majority of the data. So the problem with this one is the outlier. So we're going to put, okay, get a pen going here. Outlier pulls the line upward. And now if we look at the very last example, it's kind of strange in a sense that majority of my data is approximately at 7, and it appears that everything's going straight up. But then what happens is I have this outlier out here. Now, when I see something like this, I would even be debatable to even say whether a relationship exists. Um, Now, I don't know exactly what this one's measuring because I don't have what's on the dependent and independent axes here. But it almost looks like it should be a bar graph or a histogram because there seems to be this and all of a sudden just this one point here. So I would say that either there's no relationship, it might not be too variable, there's not enough data to make this line of best fit based on what I'm seeing right now. So in this case, if someone asked me what is wrong here, what was the misuse, I could say a few different things. I would question whether this is even two variable, whether this is two variable. Because remember, you can get the graphing calculator to graph whatever you want it to. Doesn't mean that you should, though. Um, need more, sorry, that should be a D. Need more data to make a model, right? So there's quite a few things going on there that we don't have enough information to make an educated guess, if you want to say. Now, the other thing that we're going to look at is reliability. We looked at it before when we looked at correlation, that if something was strong, the relationship that the data points were close together, made it much more reliable. But we can also make some other statements. If I have a small set of data, it's something like that last one, it is usually less reliable than a model based on a large data set. So if I only have 3 points is not enough for me to make a prediction. The same thing with reliability. I can use a linear model for a nonlinear data set, but it's not going to be reliable at certain locations. So if I actually went back up to the one here that had the wrong regression, and I actually made a line of best fit that went like this, you can see that in some places, if I use that line, I would actually have fairly reliable data. But the problem happens is what happens after I get to 10? Well, it actually is starting to decrease. So this line, if I extended it, would not be very accurate for extremes of a nonlinear relationship. It'd be okay for part of it, but it wouldn't be very reliable for anywhere else. Okay, so what you're going to be looking at now is looking at misuse and looking at reliability and making choices. So actually some thinking, not a whole lot of mathematical computation on this whole unit. However, it's making you think about what you have and what kind of predictions you can make with it. So have some mathematical pleasure.